carry on.
So hello everyone, I'm Rebecca Lee, I'm from the Wildfowl Wetlands Trust, and I'm going to be talking about our experience using Headstarting as a conservation tool for shorebirds, and using the spoonbill sandpiper as an example in one of the case studies. So I thought I would start with this slide rather than end with it, because this presentation is a summary of work that has been done in collaboration with many organisations and funders and individuals, colleagues, volunteers. So when I say we during this presentation, it really is on behalf of many more people than just me or my organisation. So what is Headstarting? So in simple terms, it's an intervention to increase breeding success. Young animals are raised in captivity and then released back into the wild at a less vulnerable stage. And it allows a greater proportion of young to survive. So in species like waders, where productivity or fledglings per pair can be quite low, even in healthy populations, Headstarting can be used to produce more fledglings than would be expected in the wild. And there's a few photos there to show you the basic kind of captive stages of Headstarting. But as you can imagine, there's lots of processes that go on in relation to those stages. So before eggs are ever collected, it's very important to establish the conservation case and make sure Headstarting is an appropriate intervention, getting all the licenses in place, finding the nests, which of course relies on good knowledge of the breeding site and fieldcraft. And then when you're rearing the birds, it's very different to rearing birds for a life in captivity. You have to rear them to be able to survive in the wild. So they need to be acclimatized, they need to be screened for pathogens throughout, and of course marked before they're released. And when birds are released, the work doesn't end, and that's when post-release monitoring begins, of course, which is also a vital element for this conservation technique. So Headstarting can be used for lots of different outcomes, lots of different reasons. I think these three are probably the main ones, and they're the reason that we have done Headstarting for shorebirds. So number one, to accelerate the recovery of a population after the causes of decline have been addressed. So perhaps new habitat has been created or predators have been reduced, but a population is critically small and it needs a bit of help getting on the path to recovery. Number two, to maintain a threatened population while the causes of decline are being addressed. So it might take many years to affect change on survival, for example, but we can, for a small population, work to maintain the birds in that population while those other issues are being addressed. And the third reason is more of a practical one than a biological one, but Headstarting is sometimes a cost-effective alternative to more traditional reintroduction techniques that rely on captive breeding populations. It's quicker, it costs less, and in most cases involves less risks. So looking a little bit more then at how you kind of achieve some of those outcomes. So there's three key factors really: the number of fledglings that you can produce from the eggs taken from wild pairs. And with good aviculture, we've found that you can produce 3 or more from 4 eggs. And then of course, it's not just about the numbers of birds that are released, but their fitness and their ability to survive. So you would be better off releasing a smaller number of healthy, fit birds than you would big numbers of birds that are not going to survive. And then the third factor is the size of the target population. So Headstarting is very much a tool that works for small populations because it needs to have an impact on the productivity of the population as a whole, and not just the productivity or the breeding success of the pairs that eggs are collected from. So I've got a very simple, oversimplified example there. I won't go through that, but it's just to make the point that we can work with very few birds, very few nests, but for a small population, a threatened population, you can have a very significant and very quick impact on the productivity of that population as a whole by working with, so that the numbers always sound small with Headstarting, but it's that impact on population productivity that can be quite significant. So I'm going to very briefly talk about 2 case studies. Both of them are ongoing, so there's not final results to present, but I'll tell you a little bit about what we've done and what we've learned so far. So first of all, the spoonbill sandpiper in this flyway. Like Nigel said, when we got involved in around 2009, the population was thought to be declining very rapidly and extinction was predicted fairly imminently. We knew that productivity seemed okay, adult survival seemed okay, but juvenile survival was low. And we knew that it was going to take many years, maybe decades, to address some of those problems that were causing low survival. So in this case, we implemented Headstarting for that reason number 2 that I had previously, to maintain the population, or to try to maintain the population while these more longer term solutions were being found. And there's a few photos of the work. So eggs hatching, chicks in an artificial brooding environment, inside the rearing pen, and then the release pen in the context of the release site. And Birds Russia are a very key partner in this. They very much lead the expeditions to Minor Pogoner every year. And with Birds Russia, we've released over 200 birds since 2012. And those birds have been seen over 300 times in the Flyway in 8 countries. They seem to be following, the migratory route and the migratory timing that you'd expect, and they have returned to breed every year. There will hopefully be a full analysis of the impact that Headstarting has had or is having this winter, but preliminary analysis suggests that Headstarting could be slowing the global decline by 3%. So that's working with a very small number of pairs in Minor Pogoner, but having an impact on the global population. And then our second case study, another project that we're currently working on. This one is for the black-tailed Godwit, and sorry. And we're specifically working on the UK breeding population. This graph shows what has happened at one of the key breeding sites in the UK. So a population decline from around 60 pairs down to 3 pairs. Habitat was created to avoid some of the problems that had driven that decline, but by the time the habitat was ready, there were only 3 pairs left. And so in this case, Headstarting has been implemented along with lots of other measures as part of a wider conservation project to accelerate the recovery of that population. So in 2017, when we started, there were 3 pairs breeding at just one quite small created wetland. And to work out if Headstarting was appropriate, we did a justification assessment, which included population modelling, and we had to see what impact we could have and whether it was going to be a big enough impact to justify Headstarting, and whether it was going to be sort of a cost-effective approach. But we didn't know, we can't predict the future at these new created wet grassland sites, and so we had to model 2 different scenarios. One where ongoing productivity was relatively good at 0.7, so that's scenario 1. And a second scenario where underlying productivity was not so good and not good enough for population stability. So if you look at the solid line on both those graphs, you can see on the blue graph, the population is very slowly increasing, but would take decades to even reach 18 pairs. And in scenario 2, you can see a population very slowly declining, getting to 0 to 1 pairs in a decade or a couple of decades. So in scenario 1, the impact that Headstarting would have, it provide a short, sharp boost to the population over 5 years, if it worked, of course. And when Headstarting stopped, then the population would go back to its trajectory based on its underlying productivity, but we would have brought that growth curve of the population many decades forward, so that we would get recovery back on track much quicker. And in the second scenario, so after Headstarting, after that boost of 5 years, the population would then continue to decline, because Headstarting itself wouldn't be changing the trajectory of the population, but we would be providing birds to study to work out what was going wrong at those sites. And we would, again, be delaying the kind of dwindling of that population by quite a few decades. So with black-tailed Godwits, we've released 112 birds over 3 years. We couldn't release any this year because of the pandemic, and we hope to release them again next year and the year after. So it's a 5-year project altogether. Again, the birds have been seen throughout the Flyway. They seem to be migrating appropriately to the right places at the right times, and preliminary results show that 56% of the birds released are surviving to at least 1 year old, and 48% of all the birds released are returning back to exactly where we want them to our target breeding sites. And that has had and impact on the population. So the population has gone from 3 pairs at the start to now 17 to 18 pairs, and they're breeding at 2 created wet grasslands, which is another good result for the project so far. And if we go back to the population models, you can see that the population growth in both scenarios is following what we predicted might happen. So we're achieving those targets, and the population model looks generally like it. You know, our survival estimates for those birds and recruitment seem to be true. The only difference is that what's happening is happening 1 year earlier than we predicted, because the birds are coming back and breeding 1 year younger than we thought they would. And this is the final slide, and sorry, I've put quite a lot on this slide, but on the left is a flowchart of the stages that we go through with planning a head starting project. So the brown and the yellow sections are the pre-project stuff. So establishing the conservation case, doing a feasibility assessment, doing disease risk analysis, and doing all those things so that a good decision can be made about whether or not to proceed. Green is the captive elements, and then blue is the monitoring and the reporting. I'm very much putting those into a feedback loop so that we're constantly trying to improve what we do on an annual basis. And then I thought it would be useful to perhaps end on some of the challenges we have for this conservation tool. So one of the key ones is that we need to of course, not use it inappropriately, to only use it where it is going to have an impact and it's not going to cause any negative problems, but also not to miss opportunities, so to get those decisions right. Number 2 is to avoid past mistakes, so learn from other work. And there's been decades and decades of experience of head starting in the herpetology world, and lots in the literature, and also learning from other methods that are similar. So reintroduction, more traditional reintroduction projects, any project with a release of birds, for example, there's a lot to learn. There's been a lot of failure, to be honest, which means that there's kind of, if anything, more to learn from that. And some of the key things that help these projects is having clearly defined success, which sounds obvious, but quite often is not done. Having clear targets that are based on a population model. Recognizing and managing risks very carefully. Having a multidisciplinary team and involving expertise from both the in situ world and the ex situ world. So people that really understand the species in the wild, but also the people that really understand how to breed, how to rear good birds in captivity that can survive in the wild. And also, of course, monitoring and reporting outcomes and sharing failures as much as successes. And then number 3, so because this technique is applied quite often to very small threatened populations, it's not usually possible to do anything experimental. But so it means it's a bit more of a challenge to learn, but we can do that by designing effective trials and working closely in collaboration with scientists, and learning as much as we can while still applying best practice and doing what we think is best for that very small threatened population. And it's very important that that's done in a very sort of timely fashion, that what can be learned can then be applied to improve the project on a yearly basis, and it's not something that we sort of wait for years after a project has ended to see the results. And one final point, of course, I've said it before, but of course, head starting, a key thing is understanding that head starting will not change the long-term trajectory of a population. It's a short-term measure, and it needs to be done in concert with lots of other conservation measures, part of a broader conservation program, if it's going to have a long-term impact past those initial years of release. So that's it for me.